Hi again. So we're continuing with ANOVA, and I want to look at how this F statistic came about. We want to look at means and variation, and why we need to look at both of these for multiple means. Okay, so I've got a great image here with 3 sets of side-by-side box plots, okay? This image is taken from a textbook. It's a Locke book, Unlocking the Power of Data, and they're the same folks who made StatKey. So really wonderful book. I need to add a citation for this in the notes. So I want to look at these 3 sets of side-by-side box plots. So notice here, dataset A has 3 groups, right, in it, and dataset B also has 3 groups in it, and dataset C also has 3 groups, okay? Now we have some certain characteristics I really liked about this image. So, and also, just like I did before, they have marked the mean inside each box plot, so you can see how the mean compares to the box plot. Okay, so data sets A and B have the same group means. So notice between A and B, the little, there they have kind of like a plus with a circle around it, is the same. So the first group is at the bottom. The first group has the same mean. The second group has the same mean. The third group has the same mean. What's changing is the spread. And then data sets A and C have the same spreads. So they've taken the box plots in A and they've moved the means out, but the width of the box plot is the same. Okay, so they have the same spread or variation. Okay, so what are we going to do here? Between data sets A and B, which has the strongest evidence of a difference in means? Okay, so first let's look just at A and B for a moment, okay? Between these two, which has the strongest evidence of a difference in means? What do you think? And take a moment and pause it. They have the same means. It was set up this way. But in A, the box plots are a lot bigger, right? So there's a lot more overlap. They're a lot wider because there's more spread, right? So the data sets are a lot wider. There's a lot of overlap. Versus dataset B, these are very narrow. They look like little TIE fighters in Star Wars. These are very narrow and not very much overlap. In fact, between this group 1 and 3, maybe not any, or just a tiny bit of overlap, right? So if you thought that B gives you a little stronger evidence of a difference in means, you would be correct, okay? And then let's compare that to, we'll compare it to the third one in just a minute. Just need to get my notes out here. Oh, and I didn't switch back to the right glasses. Okay, lots of things going on here. So if you said between these two, B, data set B has stronger evidence for a difference. Make sure that's on there. For a difference in means. Oh my gosh. Dataset B has stronger evidence for a difference in means because there is little to no overlap. Okay, so does this make the case for you of why we need to consider the variation along with the mean? Okay, and now I don't know. A might be significant, but I don't know. But B definitely has stronger evidence, wouldn't you say? That these look very different. These, I'm not sure how different they are because the box, like the middle 50%, the interquartile ranges are almost identical, at least between the top and bottom, and the middle one's a little bit different from that. Okay, then what do you think about data set C? Now that we've talked about those two. So this one, these are also quite a bit different because they've taken data set A, but they've spread them out, right? So now these look more significantly different than A, right? So C also looks like there's a significant difference. But there is some overlap, right? There's still some overlap between group 1 and group 3 and group 2 and group 3, but no overlap between 1 and 2. Okay, so let's just write some observations down here. C also looks like the means are significantly different, even though there is overlap. Okay, so it really looks like the means need to be further apart to show a significant difference in C than in A, right? If there's more spread, the means need to be further apart to show a significant difference, right? So the means need to be further apart to show significant difference when the spread is high, when the spread is higher. Okay, so that is why we're looking at the variance as well as the mean. And we're using, even though you don't see the variance on the box plot, you can see the spread and compare the spread more easily on a box plot than on a histogram. Okay, so I hope I've convinced you that this is why we need to consider the spread or variance as well. And I don't know why they chose the name analysis of variance, because we are considering both. So you could look up the history on that if you're interested in that. Okay, so here's a little summary of that. So let's see if there's anything new to add or just refresh. Comparing data sets A and B shows us we need to consider the variation along with the difference in the means, okay? Just knowing the sample means is not enough. And then this is kind of the second part. If the values within each sample are very close, then small differences may be significant, as in data set B. Okay, so that's a different way to state that. If there is more variation in the samples, then we need, I think I have a typo there, then we need the group means to be further apart to be significant, as in data set C. We need, this should be a the, we need the group means to be further apart. Okay, so hopefully that made the case to you. And so this leads us to considering two things, okay? And we're going to do a ratio of two things. This leads us to consider a ratio of the two types of variation. We want to compare the differences in the means relative to the average spread. And I have that in quotes because it's like sort of a measure of the average spread, okay? So we're going to compute two quantities and divide them. So we use division for a ratio. And so we can call it the F ratio, the F statistic or F ratio. The F ratio is roughly the proportion of allowed variation used by the differences in the means. So it's kind of roughly the difference in the means, it's some kind of measure of how different the means are, over some kind of measure of the average spread. Okay, interesting, huh? And one other thing I wanted to mention on this image is here all three groups have about the same variation in each set. That might not be the case, right? It just happens to be the way this image was drawn, so we can take a look at that also with our data set. Okay, let me put this back up, and I'm going to switch to the next page. We will continue. I'm going to show you how we're going to calculate this F ratio. Okay, so this is kind of a formula written out in words. I'm going to use some more vocabulary in the next page. Okay, so now I'm going to switch to a little more vocabulary that you'll see. The F ratio is the variation between groups over the variation within groups. So you'll see this variation between and variation within in a lot of textbooks, okay? And the between, I just want to remember, between is the means, and within is the spread. Okay. Great. So now we need to compare the variation between the groups, okay? Now, in order to do that, we have something we actually don't have yet, this number, is we don't have the overall mean of all the data. Okay, so we can use our spreadsheet for that. Unfortunately, Staplet doesn't give us that number. There's a way we could find it, and I'll show you that. But we're going to use our spreadsheet to find the mean of all, and we're going to call that capital X bar, okay? So we're going to use little x bar for the groups and a capital X bar for the total, for all of the, not the total, but the mean of all. And you may have seen, when I scrolled down here, you may have seen I have an overall average here. So the spreadsheet command is average, equal average, and it thinks I want just that middle column, which is a reasonable assumption, but I'm going to not do the titles. So I'm going to go from A3 and select and drag my mouse down to C27. Okay, or you could type A3 colon C27, and I'm going to close my parenthesis and enter. Okay, so if I put my mouse on that cell, then you can see the formula equals average A3 to C27. And I get 6,598.8 microliters, right? So let me write this down, and then I'll switch. Usually, there's really not a difference between using a capital X bar and a lowercase x bar, and so you'll see that's kind of, you probably have noticed it goes back and forth in my open math. I never know which one to use, but in this case there is a difference. Okay, so I've got my x bar equals 6598.8, and these are microliters. Okay. Oh, also I'll just write down the spreadsheet command I used. Equals average, and then we did A3 colon C27. Okay, in case you need that for later. Okay, also let's go back and put that, so we had our original box plots here. Let's go back and see where that falls, okay? So that is 65, about 6,600 to make it easy. 66, so about right here. I do actually have a ruler right here, which is handy. 65, 66 would be about a fifth of the way over. Okay, interesting, huh? So that's our capital X bar. So to get sort of this difference of the means, we're going to see how far each one is from the overall mean. Okay, so you can see this middle one's not very different at all. These two are different. Okay, so that's going to give us a measure of the difference of the means. Okay, just kind of like your standard deviation, similar to that. Okay, so let's see how we're going to do that. So this is the variation between, so the top number, and you'll see that we're going to use the word MSG later on. There is a lot of vocabulary for this, so I want to not emphasize that at first very much and just focus on the process and then work on the vocabulary. Okay, but in different books you'll see MSG or MST. Okay, so what we're doing is we need a measure of how far away the means are from the overall mean. And we have a certain number of groups, right? Here we have 3 groups. We use the letter K for that. So our degrees of freedom are K minus 1. So we have K groups. Degrees of freedom are K minus 1. Okay, so here's our formula for this. So the variation between, and we're going to be adding things, right? That's what the summation is, for each term. So we have 3 groups, so we're going to have 3 terms. That's what the I is for. So group 1, N, and then X sub I minus the capital X bar. So that's the group mean minus the overall mean, squared, because otherwise the plus or minus would cancel each other out, over our degrees of freedom, which is K minus 1. Okay? Okay, the formula looks more daunting than it is, so let's just do this. We're going to do it for each term, so I'm going to make sure I have space to write out all 3 terms here. Okay, so our first N, so N sub I. Now, it's really nice that all 3 groups are 25, so that will make it a little easier. And then we're going to use each group mean minus the overall mean. Okay, so have these summary statistics handy, and I bet you'll guess we're going to use the S's in the denominator, right, for the spread. So okay, so I've got, just going to keep it off camera here because I've got juggling a lot of things here. So the N sub I times the difference, so parentheses, X sub I, so that is 7602.6 minus the overall average, which I have right above here, 6598.80 squared. And both of those are on top of that division bar, so I'm going to make a giant division bar because I'm going to add, right? And I'm going to add all, yeah, so all this whole sum. Notice how the sum is not in front of the bar, it's on the top of the bar. So I'm going to add, and then overall I'm going to divide by K minus 1. So that'll be 3 minus 1. Okay, so groups minus 1. Okay, so let me fill in the second one. 25 also, because the second N is also 25. This time my group mean is 6459.2 minus the same overall mean, 6598.8. I'm going to drop off that 0 just so I save a little space. Plus my third group size, also 25. That mean is 5734.6 minus the same 6598.8 parenthesis squared. Okay, so it's this sum all over the groups. Well, the degrees of freedom, so the groups minus 1. So I'll put number groups minus 1. Okay, so you see what's going on here? So we're taking a difference, similar to a standard deviation, right? We're taking a difference and squaring it, the deviation from the overall mean and squaring it. But then we're also weighting it. What if our group sizes were different? So we'd be counting the larger groups more than the smaller groups. So we're weighting it. It's almost kind of like a weighted average, or weighted deviation. We're weighting it by the size of the group, and then we're also dividing it by, so it's almost an average difference of the means, but we're using degrees of freedom. Instead of 3, we're dividing by 2. Okay, so I highly recommend Desmos calculator for this, and you know why? Because we've got a lot of opportunity to make mistakes. So I've got mine right here. So I'm going to go 25 parenthesis 7602.6 minus 6598.8 close parenthesis squared. Now I'm not going to, you know what I am going to do is I need to open with a parenthesis. Thinking ahead to when I am going to hit enter, I want it to have enter under the whole thing. Okay, but I don't want to close it yet, so I'm going to do plus inside the large parentheses. 25 times another difference, 6459.2 minus, and you could copy paste the overall mean if you wanted to, 6598.8, close the inside parenthesis squared, plus 25 times 5734.6 minus 6598.8. Parenthesis squared, and then I will close the numerator, put my denominator of 2 or 3 minus 1, whatever you prefer. Okay, let me make sure I got, yes, that is what I got. You could do the top first and then divide, but I'm just gonna, oh, actually I do want to do that. Let me get my number before I divide by 2. There is a reason for this, so I'm going to write that down. 44,348, 606. These are huge numbers, right? This is brain volumes. 44,348, 606. Okay, this isn't exactly brain volume, but the brain volumes are giving us very large numbers here. Okay, so that was the multiplying and squaring and adding. Okay, then when I divide by 2, then I want to also write that number down. So let's see if I still have all the parentheses that I wanted. I still have the one in the front. Yes. Now I can just divide by 2. And I get half of that. You might notice that these are numbers in that table, which is why I want both of them. And remember how I said we divide by the degrees of freedom? So 221,74303. Okay, these don't really have units because they're squared and all kinds of things happening. Okay. Great. So that is all that to get our top number, right? So not only is, this a ratio, but the top and bottom are both ratios also. So if we wrote it all out at 1, we'd have like 4 things. And so we're going to do those separately. So that is the variation between the groups, okay? Next, we're going to go to the variation within the groups.